In this video, we will discuss one of the classic application of derivative in physics. Let's start from the simple scenario, right? So we have a moving object, but so far let's try to put a restriction on the path of the object. So let's make our object moving in a straight line with coordinates for sure. So let uh, s equal to f of t here, right? Be the displacement function uh, of an object moving in a straight line, either go from left to right or backward, right? So now one of the interesting question is how to decide what is the velocity of such a object, right? So how do you define the instantaneous velocity, right? So we suppose we have a time, let's call that t1, right? We want to know what's the instantaneous velocity of the object, right? So let's see this. So this is the where the object is moving. I suppose at a time equal to t1 when t here equal to, okay, let's see that. This is our f of t1, right? And so we want to know when time equal to t1, what is the instantaneous velocity, right? How do we do that? Is basically same idea. If we know how to calculate what's that called, average velocity, right? You pick a t2, different from t1 for sure. Then the average velocity uh, of the object on the interval t1, t2 is what? The difference of the displacement over the difference of time, right? So you moved f of t2 by minus f of t1. So that's the displacement. My over how much time did you use, right? T2 minus t1. So that's the average velocity of the object over an interval here, right? So so what? So you can use the same idea as the limit, right? You know the instantaneous. So then the instantaneous velocity, or sometimes we just call that velocity, right? At t1 is what? Is v t1. So this is as t2 getting closer and closer to t1, but never equal to that, f of t2 minus f of t1 over t2 minus t1, right? So you can see that this is basically equal to f prime of t1, right? So that's basically a classic application of derivative. So the derivative of the displacement is the velocity of such a object. And clearly, if you want to know the acceleration, right? So that will be the derivative of the velocity function, you get acceleration, right? So that's the average change of the velocity, and take a limit, you get acceleration, right? So that's application here. So let's see an example. Let's see one more example. One example on how do we figure out the velocity of a object if you know the displacement function. So we know that the displacement function s equal to 1 over t squared, right? So we want to know what is we want to find the velocity at t equal to 0, 1, 2, 3. Right, I try to do that. So you want to know the velocity at 3 times, right? No, not 0, right? 1, 2, 3, because the function here at is not defined at 0, only defined at uh, positive times, right? Okay, so so how do we do that? So instead of get v s prime of 1, s prime of 2, s prime of 3, let's try to get a general formula for s prime of a, right? So solution here is with fix a general representation a here greater than 0. Let's try to get velocity as a function, right? So v of a here, we should be s prime of a, which should be by our definition should be as t goes to a here, s of t minus s of a over t minus a, right? So which is plugging our function t goes to a, you get 1 over t squared minus 1 over a squared over t minus a, right? Now, now we want to cancel the 0 term, which is t minus a, right? That's a term equal to 0 as t getting closer and closer to a here. We don't have very fancy tricks. All we need to do is just to try to factor t minus a out on the numerator, which is take a common denominator, which is a squared minus t squared over t squared times a squared over t minus a, right? So if you try to factor a squared minus t squared, you get as t goes to a plus t, a minus t over t squared times a squared over t minus a, right? So you can cancel this two terms. This is negative 1 here because the y is the other one times negative 1, right? Now you can plug in a, right? So the answer is negative a plus t, which is equal to a, which is 2a, right? So you get 2 over a cube, right? So that's basically what is a velocity function in general, right? You can see that v of 1 at time equal to 1, which is negative 2. v of 2 is negative 2 over h, and v of 3 is negative 2 over 27, right? So that's basically how do we evaluate the velocity function if you know the displacement function. So that's a standard application of derivative in the area of physics. How do you handle the velocity problem?